In section 8.6, there are two ideas we're going to look at here. We're going to look at linear inequalities and absolute value inequalities. But before we get to the actual work, we need to review some notation. So remember interval notation. They look like ordered pairs, but they represent something completely different. So remember, when you see notation like this, bracket means include the number, parentheses means don't include the number. So this notation means all real numbers from 0 to 6, including 0 but not 6. Now be careful. This represents all real numbers from 0 to 6, okay, in between, but except for 6. But remember, it's not just integers. This is not 0, 1, 2, 3, 4, 5. Okay, it's all real numbers from 0 to 6, including 0, not 6. So pi is in this set, 2.8 is in this set, 5.999 is in this set. Okay, so it's not just the integers. Okay, so the instructions, what they want us to do here is to graph this. So this is one dimensional, okay? This is not an ordered pair. We're thinking all the numbers from 0 to 6. And here, I'm not interested. You don't have to put the tick marks 1, 2, 3, 4, 5 in between because we don't really care. Okay, just the important places. Okay, so it's all the numbers from 0 to 6, including 0. So I'm going to put that with a solid dot. And not including 6. So I'm going to put an open circle on 6 to indicate we're not including that. And you shade everything in between. Okay? So these two things are representing the same set. This is just a one-dimensional graph. It's on the number line. And this is just the interval notation. So these are describing the same set. Now I will tell you in the book, and I've never seen this before. I don't know why they're doing it this way. On the problem like this, they're doing this. They're putting a bracket on 0 and a parentheses on 6, which that's not how you graph things on the number line. So if you include, put a solid circle, and if you don't include, put an open circle. I mean, I've never even seen this before in a book, so don't do that. Okay, let's do the next one. All right, so this is everything from -4, not including -4, to infinity. Now, infinity is not a number. Infinity is an idea, okay? Infinity means get bigger and bigger and bigger forever. So what this would be is the only important point's at -4. But I don't include -4. But notice anything bigger than that, I would. So you shade everything to the right, including the arrow. Right? So this is saying anything bigger than -4 forever. And with infinities, you always use parentheses. You never use a bracket on infinity. Again, infinity is not a number, so you can't include it. Likewise, right, this is saying from -infinity to 7. So 7's our important division point here. So we do include 7, so that's a solid point. And it's everything to -infinity, so to the left. So you shade everything to the left. Again, -infinity is not a number. It's an idea, so it's everything to the left of 7, including 7. Now, and then the last one, -infinity to infinity is exactly what you think it would be. It's just everything, right? If you're going all the way to the right, all the way to the left, you've got everything. So it's the entire number line. This is just another way of saying all real numbers. Okay, now be careful. Infinity is always on, if you use an infinity, it's always on the right, and if you always use -infinity, it's on the left. Saying infinity to -infinity makes no sense. Okay, that doesn't make any sense. Okay, so that's our interval notation. Because oftentimes, where we're headed now with our solving linear inequalities, a lot of times you'll write the answers in interval notation. That's why they're going through this. Okay, so the instructions say solve this inequality, linear inequality, and then graph the solution set. Now you need to know names of things in the course. Notice it's an inequality because it's not equals to, it's 6x minus 4 is less than or equal to. That makes it an inequality. And why is this a linear inequality? Because it's x to the first power, x to the first power. Okay, so it's a linear inequality. So you solve these just like you would a linear equation if this had been an equal sign here. Put everything with x's on one side and everything without x's on the other. So I'm going to take my time here. So I'm going to put the x's on the, well, I guess it doesn't matter. Well, let me put them on the left just so we can review an idea. I know you've done these before. Let me subtract 8x from both sides. So 6x minus 8x is -2x. And I still have a 2 on the right-hand side. So I subtracted 8x from here. That gave me a 2. Subtract 8x here, you get minus 2x. Okay, so I have the x's on the left, I'm going to put the numbers on the right, so I'm going to add 4 to both sides, and negative 2x is less than or equal to 6. So that's just like solving linear equations, that's no big deal, okay? Now here, you want to divide both sides by negative 2, but the one difference between solving linear inequalities versus equations is if you multiply or divide both sides of an inequality by a negative number, you have to change the inequality. Okay? So if I divide both sides by negative 2 here, I get x, I get negative 3, but instead of less than or equal to, it's greater than or equal to. Okay? Okay, so there's the solution. So it says graph the solution set. So graphically, what is that going to look like? Here's negative 3, includes negative 3, and it's everything bigger than that. In interval, it didn't ask for it, but in interval notation, what is the answer? It's everything from negative 3 to infinity. Okay, so that's the solution. All three of these are saying the same thing. X is greater than or equal to negative 3. Graphically, it's everything bigger than or equal to negative 3, and then in interval notation. Now, let me mention something here. Right? Something that I really would prefer you did not do, especially since you are science majors and you need to get over this, is when you're solving an equation, say, or like in a problem like this, an inequality, right here, to solve for x, you would subtract 2 from both sides. I see absolutely no reason for you to have to write negative 2's underneath it. First of all, I challenge you to find that in a textbook, right? They don't do that. It's bad form, no matter how many of your other teachers have done it. I mean, especially on the left-hand side. You know you're going to subtract 2. Why do you even need to write it? You know it's going to go away. That's why I've never understood why students feel the need to write that step. And then 8 minus 2 is 6, okay? Now, likewise, I mean, once you write a step down, don't do anything to it. Okay, if you want to do something here, write it as a new step. Okay, and I know you say, I don't know why you want to do, there's no place for laziness in mathematics, right? So, write it as a new, if you really need to divide both sides by 2 and write this step down, write it as a new step. The problem is, if you start doing all this stuff in one step, I can't follow what you're doing. You know what you're doing as you're doing it, but then you've done 3 things and I don't know what you did first, okay? So this is for my benefit so I can follow your work. But frankly, I don't know why you need that step, because when you divide this side by 2, you know you're going to get x, and then that's 3. Now the reason why I'm mentioning this, besides the fact it's just not good form, is let me come back to this problem over here. At this step, minus 2x less than or equal to 6. I know many of you would be very inclined right here to divide both sides by negative 2 and write that down. Just like that, and then go to that. The problem is, what you've written here is wrong. You divided both sides by a negative, but you didn't change the inequality. So technically what you've written here is wrong. This is why I always say, once you write a step down, don't do anything to it. Don't add to it at the end like this. Because you've just written down something that's wrong, okay? So, okay, I'll be writing down your papers. Once you write a step down, don't do anything to it, okay? Don't start adding things to it. Write it as a new step. You're less likely to make a mistake. You'll be a little more organized. Okay? And I don't want to see floating work either. 2x plus 3 equals 10. Subtract 3, subtract 3. I don't want floating numbers. Okay? Don't do that. Okay. Okay, let's do another example. This is number 37. It says negative 1 less than or equal to negative x minus 2 over 3 less than or equal to 1. So it says solve the compound inequality. A compound inequality means there's 2 of them. Now what this means is this is bigger than or equal to negative 1 and, compound means and here, and that is less than or equal to 1. Okay, so it's an and statement. That is bigger than or equal to that, while at the same time this is less than or equal to that. Okay, it says solve and then graph the solution set. Okay. Okay, well, we're trying to get x by itself. So just going with your gut, what would you do first? Well, I'd probably get rid of the 3. So let's multiply all the way through the inequality, each part of the inequality, by 3. because I'm just trying to get rid of the denominator. So that's negative 3 less than or equal to negative x minus 2 less than or equal to 3. I multiplied every term by 3. Notice I did not change the inequalities because I'm multiplying through by a positive number. Okay, next what would you do? Well, I'd probably just get rid of the negative 2. Let me add 2 all the way across. So if I add 2 to negative 3, I get negative 1. Add 2 here, the whole point was to get rid of the negative 2, you get negative x. And add 2 here, I get 5. Now we're trying to get x, so we need x by itself, or we have to get rid of the negative 1. So you can multiply through or divide by negative 1. Now be careful, I have to switch the inequalities, so multiply negative 1 by negative 1, I get 1, bigger than or equal to x, bigger than or equal to negative 5. So there's my solution. So the solution to this inequality is any value of x that's between negative 5 and 1, including the endpoints. Okay, so in interval notation, now be careful, I know I wrote it with the 1 here and the negative 5 here, but it's bigger than negative 5 and less than or equal to 1. So it's negative 5 to 1. That's the solution in interval notation. And then graphically, it's anything from negative 5 to 1 in between. And again, it's not just the integers, 0.99 is here, negative 2.72 is in here. That one wasn't too bad. Okay, so let's shift gears here for a second. Right? Suppose I had the equation absolute value of x equals 5, suppose. Okay? Absolute value equals 5. What could x be here? What number could x be to make this a true statement? Well, if x is 5, the absolute value of 5 is 5, so that would work. But there's also another solution. Negative 5 is also a solution because the absolute value of negative 5 is 5. Those are the only two solutions here. Okay, so if you have absolute value equals a non-negative number here, the solutions are plus and minus that number. Okay, that's no big deal. Okay, so let me change it in, so in general, what I mentioned in the notes there, I say, suppose absolute value of y is c. Now obviously c has to be 0 or positive, doesn't it? Because if I had absolute value of y equals negative 2, there's nothing's going to work because the absolute value is not going to be negative 2. So this has to be positive number or 0, okay? So the solutions to this are y equals c, or y equals negative c, right? Okay? So that's just if those are equal. Now let me think of this on a number line. So let's assume c is positive and not 0. So the solutions to that are here and here, right? Y is c, y is negative c. So if the absolute value of y is equal to c, those are the two solutions. Notice it's not everything in between. Because it's not an inequality, it says equals to. There are exactly two solutions to it. So that's what that would look like. Okay. Notice if c is 0, then you get 0 and negative 0. They're both 0, so there'd only be one solution at 0. Okay, so what if we change the problem here? So if the absolute value of y is equal to c, your two solutions are here and here. What if I had absolute value of y is bigger than or equal to c? Or another possibility, what if absolute value of y were less than or equal to c? So notice I've changed it from an equality, an equation, to an inequality. Okay? So how do you think solutions to this would relate to this? In fact, let me just say strictly greater than, just so we don't confuse ourselves. Notice, right, so I'm saying, notice y equals c is not a solution here, because c greater than c isn't true, right? C is not greater than c. C is not less than c. Okay, it's equal to it. Okay, so where would these solutions have to be on the number line? It seems to me solutions to these would have to be here, or here, or here, wouldn't it? Because when the absolute value of y equals c, it was here and here. So absolute value of y greater than c or less than c is going to be either here or here or here somehow. So I just imagine this picture, right? If the absolute value of y equals c, you're at c and minus c. So if absolute value of y is bigger than c or less than c, you're here, one of these. Okay? So it's just a matter of remembering. Okay? So the absolute value of y less than c is here. It's between minus c and c. So this is absolute value of y less than c. Okay, so whenever you have this is an absolute value inequality. This is an absolute value equation. Right? Absolute value of y less than c. The answers are between plus or minus c. Now, what about absolute value of y greater than c? That's out here and over here. Okay, so so here's what you have to keep straight here. So if you have an absolute value equation, you may have to do some algebra, do some simplifying, but if you get absolute value of y equals c, I know the solutions are at c and minus c. That's what the original thing is. If I get absolute value of y is strictly less than c, I know the solution is in between those two. And if I have absolute value of y is greater than c, it's everything outside of that. Those are the three possibilities. So absolute value equals c, or here and here, assuming c is a positive or 0. Absolute value y, again, c has to be positive here, or these aren't going to make sense if these are negative. Well, that would if it were negative, I suppose. But that'd be all real numbers. Anyway, okay, so you just have to remember. If you just remember absolute value y less than c is here, you know this one's out here. Right? So how could you rewrite this without the absolute value? This would mean y is between negative c and c. Right? Y is between minus and c. Now here, how do you write this as an inequality? It's y is less than negative c, or y is bigger than c. Notice it's not an and, it's an or. So anything here is a solution, anything here is a solution. So notice this, what does this mean? There's a compound inequality. Y is greater than negative c, and y is less than c. So if you write these together, that means and. That's why I didn't try to write these as one thing, because it's not an and, it's an or. So a solution here has to be between. It's bigger than that and less than that. It's in here. Here, y is bigger than c, or y can be less than negative c. So you just have to remember this picture. Now notice what I've done here. I've left out the or equals to. I said equals to here. It's those two. Strictly less than c is strictly in between. Strictly bigger than c is out here, out here. So the only modification is if you go back and put an equal to there, that would include these, so you just have to fill those in. Right? If I put equal to here, it equal to, fill it in, okay? So that's the only difference. So if you have or equal to, you just have to fill in the c and the minus c. Okay, with all that, let's finally do an example here. And when I say y here, y doesn't have to be just y or x. It could be an expression, which is what this first example is. So this says solve the inequality x minus 20, absolute value, is less than or equal to 6. Then graph the solution set. Okay. So my y here is x minus 20. Right? So in terms of getting, wrapping my head around the problem, think of this as y. If the absolute value of y is less than or equal to 6, that means the stuff in the absolute value is between minus 6 and 6, isn't it? And notice because it's or equal to, it would actually include the 6's, the 6 and minus 6. Now again, this is not, the answer is not x is between minus 6 and 6. No, it's not that. It's this is. That's like my y, okay? So to change this from an absolute value inequality to an inequality without absolute values, this means x minus 20, the y, is less than or equal to 6 or bigger than or equal to negative 6. Right? So the absolute value of that is between minus 6 and 6, including 6 and minus 6 because it's or equal to. And now we did one of these a while ago, solving a compound inequality. That's why we did those first, because you change an absolute value inequality to a compound inequality. So if you had 20 all the way across, you get 14 less than or equal to x less than or equal to, what am I adding, 20, 26. So this picture is not referring to the answer here. I was just referring it back to my thinking before. Right? So this is x minus 20 is between those two. So that's where this came from. Right? So the actual solution set, so x minus 20 was between minus 6 and 6. So x is between 14 and 26. So graphically, you include the 14 and you include the 26. So graphically, if you want interval notation, that's everything from 14 to 26, including the intervals. So there's a solution in, as a compound inequality, there's a solution in interval notation, and there's a solution graphically. Okay, let's do one more. It says solve the inequality x, absolute value of x plus 14 plus 3 is bigger than 17. Then graph the solutions. Okay, well here I think we need to do one step first. You really want to get the absolute value by itself. So let me subtract 3 from both sides. X plus 14 is greater than 14. Okay. Now remember, pictorially, think back to how we did absolute values that were bigger than a number. So just to wrap my head around this problem, right, when an absolute value of y was bigger than a number, remember where that was. It was bigger than c or less than negative c. Okay? So the y here is my x plus 14, and my c is also 14. So how do you write this? Now this is an or statement, so I'm not going to write it as a compound inequality. So this says x plus 14 is out here, or x plus 14 is over here. So x plus 14 is bigger than, the c here is 14, or x plus 14 is less than negative 14. Right? So the c is this 14 right here. So from minus 14 to 14. So x plus 14 is bigger than 14, x plus 14 is less than negative 14. So now you just have two small inequalities to solve. So here, if I subtract 14 from both sides, I get x is bigger than 0. Or, and if I subtract 14 from both sides here, you get x is less than negative 28. Notice I didn't change the inequality. I subtracted 14. I didn't multiply or divide by negative 14. Okay, that's different. Add or subtracting something from both sides doesn't change the inequality. It's when you multiply or divide by negative number. Okay, so graphically, what does this look like? Here's negative 28, here's 0. So x is strictly bigger than 0, so everything to the right of 0, or it's everything to the left of negative 28. So there's graphic. Now, if you want to write this with interval notation, you have to do it as two intervals because there's two pieces. So how do you write that in interval notation? That's negative infinity to negative 28, not including 28. So that's this piece. And then this piece is everything from 0 to infinity. Again, you never include infinity. You're not including 0 here. And whenever you have separate pieces like that, you put this symbol. It's not actually the letter U because you don't put the tail. It's U for union, okay? So if you ever have two pieces like that, or 3 or 4 pieces, this is what you do. Just write each piece separately and put a U in between. So that's that solution. Okay, that's how you do linear inequalities and absolute value inequalities.